The litmus paper cannot test them, right?
I think they, okay, okay, there is something like that. I think so, yes. Then we will search that in the internet.
Ma'am, like if you take CuSO4,
Mhm.
so copper sulfate, then also like it's a base, so there also you cannot
Copper
find like.
sulfate is a salt, it's not a base.
Is there salt, ma'am?
Yeah, copper sulfate is a salt.
No, because said it as a base because like CuSO4. So basic mostly like SO4 groups are like.
It's a salt. No, copper sulfate is salt actually. I don't know. Wait, I'll see if copper sulfate is salt or not. It's copper sulfate salt. Yes, it is an salt. It is an inorganic salt.
Ma'am, so like any like chemical with the name sulfate is a salt.
Yeah, you can take like that mostly. Yes, yes. Copper sulfate,
Okay, ma'am.
magnesium sulfate, they all come under salt. Because copper sulfate and all you can see in your eyes. It will be like
Yes,
salt.
ma'am.
You can see them in your eyes itself. And what about this homework?
Ma'am, I did not
And
like
again,
understand.
potassium sulfate, right?
Yeah, KOH is potassium sulfate.
Hmm. K2SO4 is potassium sulfate, right?
Okay, yeah. K2SO4 is potassium sulfate, yes. KOH is potassium hydroxide.
Yes, ma'am.
So, how many people completed these reactions? This one is basic, we
Ma'am,
already did in class.
ma'am, like I was not, I'm not sure. Like,
Yes, ma'am. Me too. Like somewhat like it might be mistake.
Now you can check it.
Yes.
You can check yourself the answers, everybody. This one and this one we already did. Maybe these two.
ma'am, yes, ma'am. Like I
Ma'am,
got
so
ma'am, I got
first,
the
third,
first,
and
second, and fourth. The third one I got wrong.
ma'am, I
Okay.
got the second one wrong. Like first, third, and fourth are correct.
Ma'am, I got the third
I
one
got the
wrong.
third one wrong.
Third one wrong. Everybody. Second one, everyone got right?
Yes,
Ma'am,
ma'am.
I got the second one right.
Oh, everyone got second one right. So no need to discuss about that.
Yes, ma'am.
Okay, then go to third one. What is third one? Nitric acid, that HNO3. In this, which one is H1? H. There are two hydrogen. Two H plus is there. Calcium hydroxide. So clearly OH is also 2 is there. So we know H is also 2, to OH is also 2. To basically we can put 2 water, right? Am I clear? So I'm just talking
Yes.
about
Yes,
water now.
ma'am.
First I'm talking about water. So here, so I have told you acid plus base will give you salt plus water. Okay. So always water means H2O. But we need here the problem is it is not 1 here anymore. Here it is 1, but here it is 2, and here OH is separately having 2. Am I right?
Yes, ma'am.
So it is not a linear combination. It means you have more than one. So here 2 H is there. But problem is there is no problem because OH is also having 2. OH is also 2. H is also 2. So we have 2, 2. So we can put 2 H2O. So we know that H plus and OH minus will form water, and each are having 2 in them. So OH is also 2 and H is also 2. So I can put 2 H2O, right? 2 water can be formed, right?
Yes, ma'am.
If the water is clear, then rest all, whatever is remaining, you can write it. That's all, right?
Yes, ma'am.
So what is remaining? We will write that also. So we have 2NO3 is remaining here. And here we have Ca, only Ca, right? So 2NO3 means how many nitrogen is there?
2.
One.
How many oxygen is 1? 2, 1. Who said 1?
Ma'am, yes, ma'am.
How many nitrogen? See, I have taken H and OH from this 2 and I'm just writing 2NO3 plus Ca only left. Now we know that 2H2. Everybody understood why it is
Ma'am,
2H2?
Ca2, right?
Yes, ma'am.
Yeah, now
Ma'am,
how
so
many
like
nitrogen?
there are because there are
Ma'am,
like 4 hydrogen.
Yeah.
ma'am,
So
two
yeah.
nitrogen.
How many nitrogen?
Ma'am, two.
2,
Two.
right? So we have 2 nitrogen. How many oxygen?
3.
3.
3.
3. You should multiply this 3 with this 2.
Oh.
Here this 2 is
5.
common for N and O both. So when I put N2 and for example, N2OH, for example, you just take, there is no compound like that, but for example, I'm telling you N2OH, it means this 2 belongs to N only. But if I put 2NOH, it means this 2 belongs to N, O and H, all the 3.
Oh.
Got it? How it works?
Yes, ma'am.
Ma'am, I try for the third one, I almost I got that 2H2O,
Mm-hmm.
but for that CaNO3 2 that I didn't got because I had confusion like how to add equation like chemical equations.
Yeah, so when you have two, so I have told you 2NOH means this 2 belongs to N, O and H. If it is N2OH means this 2 belongs only to N. But if the case is like this 2N2OH2, if it is like this, you can see there is a 2 that is common to N, OH, common to, and also you have separate 2 for N and separate 2 for H. In this case, what you have to
And
do, you have
so
to
N will have 4, right? And 4.
you have to okay, so if it is like this, for example, then you have 3 for N and 2 common for all the compounds and 3 is only for N. So if I ask you in this case how much N is there, you have to multiply, you have to say
6, ma'am.
2
There are
3s are
6
6
and
On the
N.
6, N6 and H6.
It's
Oh,
6.
it's 6.
How it is working, now you got it.
Okay,
Yes.
ma'am. So, can you
yes,
take one
ma'am.
other example and add it,
Haha,
another example?
we will add in this equation itself. This itself a good equation, no? So think about the same thing here. Ca is no having no problem, but take N. N is having 2 and O is 6. So I should combine these two. Actually, you know that NO3 is minus, Ca is actually plus. It's a positive ion, it's a negative ion. You should know that. By the practice, you will know. Like in future, you will know. So basically, these two can react with each other. So it's basically Ca2NO3. Instead of writing this like this, if I write like this, it's not looking good. So I am just simply rearranging the equation. That's all. I'm just not doing anything else. So this is not the correct way to write. Numbers can come only in the front or it can come in the subscript like this down, but it cannot come in the middle like this. So this is not the correct way to write. So what I'm just doing, I'm reframing like that, like NO3 and 2 belongs only to sorry, only to NO3 group. So this 2 is now common for NO. Yes?
Yes, ma'am.
Why I am writing like that? Because as
Yes,
per
ma'am.
the rule, we cannot have a number like this in the middle of the two compounds. It's not correct. So as you have grammar in your English, like that, you have some grammar in this equations also. So as per the rule, you cannot have the number in between like this. So I have to take this 2, I have to put this 2 common to both N and O. So I am just using like this, putting it as a subscript. So this 2 now belongs to, don't forget to put the bracket. So if you put this bracket, it means this 2 is common for N and 2 is common for O, both.
Yes, ma'am.
Now you got how you got the byproduct, how you are getting this byproduct. Everybody understood?
Yes,
Yes,
Water
ma'am.
is very simple. Water is very simple. You have 2H and you have 2OH. So just put 2H2O, that's all. And rest all is same. Yes?
Yes, ma'am.
Everybody in the meeting understood? Gilda,
Yes, ma'am.
Aishwarya,
Yes, ma'am.
Ma'am, understood.
Manas,
Yes, ma'am.
Muhammad, Muhammad, Afan.
Yes, ma'am, understood.
Afan, why Hamza is not joining?
Ma'am, because he is in the same place like you in like Abu Dhabi. Yeah, and why, like yeah, he has exams going on. That's why he's not joining.
Okay, fine. Oh, okay. I want to talk to his mother. So, okay, I'll talk, no
Yeah,
problem.
I do you have a number?
Can you give the number?
Yes, I will give after class.
Okay, okay. You message me, okay?
Okay, ma'am.
Okay, fine. Okay, everybody understood, I hope. Yes?
Yes, sir.
So now you can see the difference. Somewhat the complexity of the equations are getting higher and higher. So first we were dealing with the simple equations. Now somewhat complexity has increased. Now the complexity will be increasing more. But no need to worry. It will be easy to understand. Yes. You should never forget the logic acid plus base always gives you salt plus water. And whenever you are dealing with any kind of this sort of equations, always first resolve this problem of water. First complete the water problem, and then whatever is remaining you can easily rewrite. That's all. First always concentrate in water. Okay, so we're discussing about the litmus paper. So we have seen the feature of the litmus paper: color change, simple and quick, and range. And now, see, these are some questions you can try. It's very easy questions. People, you can try and tell me the answer. Yeah.
Ma'am?
Yeah.
But like, what is the difference between red and blue litmus paper?
There is no difference. So litmus paper is stripped like this. So when you insert the strip inside the acid or base, this part of the color changes. So based on the color change in this part, you can find whether it is a acid or base.
Um,
Yeah.
Ma'am,
First one got.
it is I think
Ma'am, the first one.
Mm-hmm.
ma'am, the first one is like pH of 3 will
The
be acid, right?
Yeah.
It's acid and the litmus paper turns red.
Red.
Okay, that is the correct answer. So everybody got the same answer?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Ma'am.
ma'am. Yes, ma'am.
So if it is acid, red turns to blue, ARB. If it is a base, turns to red, BBR. So if it is 1 to 6, it is acid. If it is 7, if it is 8 to 14, it is base. So these things you remember. You can easily answer all these questions. Yeah, second one.
So the strip of red
I'm in the
litmus
first.
paper turns into blue,
Ma'am, it will turn into blue.
and it's
Because it
like
is different to the base.
it's like a base.
Okay, somebody asked first ones like that they started.
Ma'am, the first one you said like RB, but they said they dip blue and it'll become red, right? Not
They
red.
dip a strip of blue litmus paper into the solution. So into the solution, they're dipping the blue litmus. What is the resultant color of the litmus paper? So if it is an acid, it turns what? Acid, it turns red to blue, right?
Yes, ma'am.
So the answer maybe it will turn the blue to red. No,
Okay.
it's like vice versa.
Okay.
Understood? Yeah.
Ma'am, like for the
And
second
so
one,
like
like
in a acid solution, if we put a red litmus paper, it turns blue.
Yeah, of course.
Yeah, ma'am.
Yes, correct. So yeah, second one. Everybody got first one answer. Gelda, no doubt in the first one.
No, no, this is very easy only.
Ma'am, no
Yeah,
doubt.
it's very easy actually. Advika
Yes, ma'am.
got
Ma'am,
the
this is
first one.
easy.
Yes, ma'am. Ma'am, it
Yes.
turns red.
And
Yeah.
the second one, like
Somebody is calling me. Yeah. Aishwarya.
ma'am,
Yes. Yeah. Aishwarya, yes. Yeah. Tell me, Aishwarya, yes. Am I audible? I'm not audible or what?
yeah, you're
Ma'am, you
audible.
are.
Yeah.
I got disconnected, so can you explain what you just explained,
No,
ma'am?
just I'm asking questions, Aishwarya. Just try this question and tell me what answer you're getting.
Okay.
ma'am, so the second one, the red litmus paper turns into blue
Yeah.
because it has a pH of 9 and it's a base.
Yeah.
Ma'am, even if it has a pH of 3, like you said, vice versa, if we keep a red litmus paper, it'll turn blue.
Yeah.
So, ma'am, it's like the same for acid and base.
No. See, you didn't see this diagram properly. See here. This is an acidic solution. Blue litmus turns to red, but where it is turning to red? Can you see this is a blue litmus paper? It is turning to red color inside the solution, right?
Okay,
And
ma'am.
it is a red litmus paper. See, this is a basic solution. Basic solution turns red litmus to blue. So it has turned here to blue. This
Ma'am,
is
so like
universal.
what if we put a blue litmus paper into no red litmus paper into acidic solution?
It will just be red.
No, I'm not getting what.
Ma'am, so like blue litmus paper turns into red one when we put it in an acidic solution.
Blue turns to red when it is acidic. Okay.
Yes, ma'am. So what if we put a red color litmus paper in acid?
I think no change will be there, right?
Yeah, ma'am.
So in that case, you should use universal pH paper. See, this universal pH paper is yellow in color. So that will turn to red or blue based on the solution. So it is basic here, so it has turned into blue. So if I put this universal pH paper, that is yellow color pH paper, into acidic solution, it will turn to
Red.
yeah. Yes.
Yes, ma'am.
If you put a acidic solution, the red color into acidic solution, 90% I think no change will be there, according to my knowledge, according to my guesses.
Ma'am, so like depending upon the like how much acidic it is.
Ma'am,
Yeah.
ma'am, the answer for the third one is like first when you dip it, it will be like red color, and next time you dip it, it will be for the pH
Yeah.
7 it will be green, and for the pH 10 it will be still blue.
Yes, ma'am. Same.
Yes, ma'am.
So got it now? This question is also somewhat, if you think you will get the answer.
Yes, ma'am. Like it is the same like which you gave an example.
Yeah. Third, fourth one. Yeah, fourth one. Chemical engineer tests a solution and find that it turns red litmus paper to blue.
Ma'am, it means like is it taking like base from 8 to 14?
Yeah, it is. First question is right. 8 to 14,
Yes,
it will be
it's
ranging.
base.
So red it turned to blue. Red turned to blue means it is
Base.
Ma'am,
yes.
can you just tell what we did before and network issues?
See here, if it is no, nothing. We are just discussing about the questions are fun. Just if you have found the answer for these three questions, then
Not
it's
Afan,
fine.
it's Hamza. Hamza joined now.
Hamza joined now.
Ma'am, I had network issues.
Okay. So Hamza, you were not joining yesterday, right?
Ma'am, yesterday because it was like Eid holidays and I was not here.
Okay, fine. So after this class, we will talk. Okay.
Okay, ma'am.
And you have some doubts in this? You joined late, that's why I'm asking.
Yeah, ma'am.
Do you have some doubts? Am I audible?
Ma'am, like 1 week ago, I didn't know about this lesson because I was having exams.
Yeah. So this lesson is new to you, I guess.
Yes, ma'am.
And also in electricity chapter, you were not there while completing. Am I
Ma'am,
right?
yes, ma'am.
Fine, we'll talk about that later. So just listen the class. If you don't understand, that is completely fine, okay? Just
Yeah,
listen
ma'am.
it. Yeah. So what we were talking? We were talking about this. See here, red litmus turns to, it is like chemical engineer test a solution that turns red litmus to blue. It means red is turning to blue means it's a basic,
Base.
okay?
Yes,
It's basic. It can be ranging from 8 to 14, that is correct. And then next question is the engineer knows that pH value, okay. What engineer can conclude about this minimum possible pH can be 8, no?
yes, ma'am. It's
Yes,
like
ma'am. It,
8
told
minimum.
Maximum possible maybe 14.
14.
ma'am, like I learned this chapter not in depth, like the what do we say, like little bit of this chapter in grade 6. It was our topic.
Yeah. So how to use? So what is the process basically? Dip a strip of litmus paper into the solution you want to test. Observe the color change. If the red litmus paper turns blue, the solution is basic. If the If the blue litmus paper turns to red, the solution is acidic. We know this. Compare the color change to a pH color chart if more precise measurement is needed. So as I told you, if you just want to simply tell me it's a basic or acidic, you can just tell me with the help of color change. But if I want a precise measurement like this, is it like precise measurement like this, color with the level, with the number of the
Is
pH,
related to like chromography?
you can say, but not related, actually, not at all related. Just we are using colors to identify the pH
No,
level,
ma'am,
exact
like
pH
in
level.
process of chromography will be color one side with dot and another side with dot, and then the increase.
Yeah.
I have a doubt.
Yeah.
Like, can we use this litmus paper in measuring the acidity of a human being?
Wherever the acid is present, you can use. No issues.
Yeah, ma'am.
But
So, like,
it's not like.
how
Mhm.
can we like measure it? Like, it should be a solution only, right?
Yeah, it should be, and that is what I am trying to say. It should be like you should have the setup. You should have the beaker. You should have the acidic solution in that or basic solution in that. Only then it will be possible, right?
Yes.
Yeah. So you should have the apparatus ready. Compare the color change to a pH color chart if more precise. And while litmus paper is useful for quick and general pH testing, it is less accurate than the other pH indicators such as pH meters, or nowadays we have pH meters. They are more digitally advanced. And universal indicator paper. Universal indicator paper, we saw that yellow
I'm
color
like,
strip.
according to me, like the most accurate I have seen is that universal indicator like I have tested. That it shows the accurate.
Yeah. Nowadays we have advanced technologies, not just pH paper. We have advanced technologies to test it.
I'm
So
like,
with
how is the pH paper made?
yeah, so that was. Can anybody tell how it is made? Yesterday we saw.
Ma'am, it's made by like
Mhm.
insect
Like,
um
made of dyes.
legends.
Lichens, yeah. It's actually made up of dyes. It's just normal color, natural dyes. We can say them as a natural dye because we are getting it from lichens. And can anybody tell me the name of the lichen, if you remember?
Ma'am, the name of the
Lichens.
Ma'am, your voice is so
Ma'am, but
ma'am.
I don't remember the name, but it starts with R.
Yeah. So something even I
And
forgot.
oh,
Yes, yes, yes. Even I forgot. Yeah, Rochella and Lecanero.
Yes.
So basically, they are formed by the symbiotic relationship of these lichens. That is a fungi and an algae or cyanobacteria. We already know what is the symbiotic association and everything. I don't want to explain.
Yes, ma'am.
Yeah, because of them, from them we are getting these colors. From them we are preparing these litmus papers. Yeah.
Yes.
Yes,
Okay,
ma'am,
we
understood.
can move to acids. So these are the next slides. No, next slides are very basic only. No, nothing is there. And after that, we'll go to somewhat deeper into the chapter. Yes, so acids. So acidity is a characteristic property of acids. So acidic substance usually very they are. So this is a very important point. Acids are usually very sour. Apart from hydrochloric acid, there are many other type of acids around us. We already know that citrus fruits like lemon, orange contain citric and ascorbic acids, while tamarind paste contains tartaric acid. So tamarind has tartaric acid, and citrus fruits like lemon and oranges have citric acid, and we have lot of other acids, right? And in fact, the word acid and acidity are derived from the Latin word acidus, which means sour. So this is very important. One more question.
The meaning of acid is I learned it sixth grade.
Yeah. So it means sour. If you dip a blue litmus paper into acid, it will turn to red, while red litmus paper will not change color. So somebody asked me this doubt, no? So see, it's there here. Acids also liberate dihydrogen when they react with metals. So they liberate dihydrogen. So what do you mean by this di and hydrogen? Yes. Yes, somebody.
It's a thing in acid.
No, I'm asking you what is dihydrogen. Just divide the word. Di means two. Hydrogen means hydrogen. So it's H2 basically, no?
Yes, ma'am.
Yeah. Now, shall we do this experiment and see what's happening? I don't know. I'll do with you. So they're telling acids or liberate dihydrogen when they react with some metals. So some metals, for example, we can take HCl, very common acid, okay? Or we can take H2SO4. We can take
I
H2SO4.
will take HCl, like it's easy to remember.
H2SO. We'll do with HCl again once again. And we can take aluminum is a good metal, no AI.
Yes, ma'am.
Yes, ma'am.
So we know that it liberates dihydrogen. It means H2 will be liberated. So what is the remaining part?
SO4 and AI.
SO4.
AiSO4. So what is this
Yes.
basically? Aluminum?
Aluminum sulfate.
Yeah, it's Ai. Aluminum sulfate, exactly. So aluminum sulfate is an
Salt.
salt.
Yes, ma'am.
Salt.
Yeah. So
Yes, ma'am.
can you make a huge point here? Can anybody make a very important and huge point? When an acid is reacting with a base, it gives salt plus water. But when an acid is reacting with a metal, we can say they can release salt and hydrogen. Yes.
Yes.
I'm telling you, this is just an hypothesis. I don't have any proof for this. I have taken aluminum, so I'm getting salt and hydrogen. Maybe I'll take any other
Can
metal.
we take like another one like metal?
We can take, for example, we can take this time HCl. We can take lithium. Lithium is also a metal. You know, I think so.
Yes, ma'am.
Lithium is a metal, no? Or we can take iron, ferrous,
Yes,
Fe.
iron. Ferrous. Fe.
Shall we take ferrous?
I
Fe.
wanted to
Okay,
try
ma'am.
Okay, well, what happens now? H2
plus
will come. We
H2 will
know, we're very sure that H2 will come. But one
only.
blender mistake is here. Can
Ma'am, it will
anybody
be
tell me?
only H, right?
In the left hand side, there is only one H. So I have to balance the equation now.
Yes.
So what can I do?
Uh,
Can I put 2 here? Yes, I
And
can
so
put.
2 hydrochloric acid.
I can put 2, 3, 4 for balancing my equation. That is my wish. There is no problem in that. There is no issue in that.
Yes, ma'am.
Because for sure I know that dihydrogen should release as per this condition. As per this condition, dihydrogen should come out. But I have only one hydrogen as HCl is
so
having
we'll
only
put
one.
2 in front. It means like hydrogen and C
Yeah.
and I both will have
So
that.
this 2
Ma'am,
H,
if there's
H is
2 in the
gone.
front, will it change the equation?
No. You're not clear, Advika. Yes?
Ma'am,
What?
will it be like 2 FeCl?
Yes, Advika asked some question. Yes?
Ma'am, like if we add 2, will the question, like the,
Mm-hmm.
it will change or like?
No, it will not change. Instead of taking one HCl, I'm taking 2 HCl and reacting with one ion. That's all. Two things instead of one thing.
Okay.
That's all. It won't change. It will change the something called as molarity. You don't do like molarity. Something is there. It will change the amount. It will change. Maybe you can say it will change the number of amount. For example, if I'm taking two what can I say? If I'm making noodles with one packet, and if I'm making the noodles with the mega family packet, will the taste change?
No, ma'am.
But quantity will change. Quantity will
Yes,
Yes,
increase.
ma'am.
ma'am. What?
Exactly. If I'm taking instead of one HCl, if I'm taking two HCl, quantity will increase. But no change will be there in any reactivity issues.
Yes.
Now I
Okay,
have
ma'am.
Fe here, so you can easily tell me the remaining.
Yes, ma'am.
Come here.
FeC.
FeCl, ferric chloride.
Yes, ma'am.
But one more problem is there. Here you
It's
have
not
two Cl, but here you have only one Cl.
escape button.
Ma'am,
Yeah.
so can we like take 2 iron?
Okay. So we can take two iron. Okay. Now how can I change this?
No.
Yeah, I can put two here.
Yes,
Easy.
I want to say that, ma'am. We are
Two
going to.
phenolic chloride.
Okay, ma'am.
Or else, if I don't want to make any change in Fe, I can make like this also. Yes.
Ma'am,
Ma'am,
the
iron
Fe Cl2. Just now we saw, right?
Yeah, the material name is ma'am now.
Ferric chloride, FeCl2.
Ferric.
Fe means
Ma'am, but
iron, right?
Yeah, Fe means iron, but you should say ferric. Ferric is a, what to say,
ma'am,
chemical
so
name.
ferric chloride is like not a salt, right?
Ferric chloride is not a salt. That is a very interesting question. Can anybody answer me? First of all, is ferric chloride a salt or not?
No,
No,
ma'am. It's a base. No, ma'am. It's like as an acid.
It's
It
an
is a
acid.
salt. It is a
Chloride is,
salt.
How, ma'am? Like it's a chloride.
ma'am, but it's a chloride, right?
Yeah, it is a chloride, but still it is a salt. It is an inorganic salt. Comes under inorganic salt.
very
Ma'am,
close.
ma'am, I thought like why are you keeping two in FeCl? Because in H2 already two is there, right?
No, no, I'm not getting you.
Ma'am, like you said that two can be, if you keep it like that, can be to any H or Cl, right? So that's
Yeah.
why you already use it on H2.
Mm-hmm.
I'm like,
How are you keeping
yeah,
it?
I'm
No,
like
no, no.
ferric,
Yeah.
ferric chloride is a salt or like it's a like sand because when I searched in Google like ferric chloride images, it was like sand.
It is looking like a sand, but it is not sand, of course, Siddhant. It is a salt. It is a salt. Ferric chloride is a salt. I know that. You can believe me, guys.
Okay.
Actually,
I will search in Google. Wait a minute. Ferric
yeah,
chloride,
I believe you now.
FeCl2. Is a ferric chloride is a paramagnetic solid with high melting point. Okay, it's a. Mm-hmm.
That's why for me also it shows like something in like and like color.
Ferric chloride, FeCl. Wait a minute. Is FeCl2 a salt? Yes, it is a salt. Yeah, it is
Okay.
confirmed it is a salt. It's a pale greenish salt like crystal or powder that's a paramagnetic and has high melting point. Okay, those things are not needed.
Ma'am, so
It's
like
a salt.
why? Ma'am, so like
And it is a yeah, yeah.
hydrochloric acid also has like a chloride, right? But
And yeah,
why
yeah.
it's an
I did a
acid?
mistake here. 1 second, Rishit. I'll tell and I'll come back to your question. I did a mistake. If it is ferrous chloride. It is not ferric. If it is ferric, you will have three. You should have three in Cl. Ferrous means, you please remember, this is a very important point, children. See, even I forgot. Ferrous, Ferrous. If you have ROUS, it is always two. If it is FERRIC, it is always three. So if it is like FeCl3, I should say it as a ferric chloride. But if it is a FeCl2, it is ferrous chloride. It is not about F here, but it is based on the chloride you have. That is also important point. Got it?
Listen,
And by the way, like, how do we mix these chemicals?
We mix in the chemical laboratory. You will be doing in
Like,
your
how do
schools.
they mix this, ma'am?
Mix in the
Ma'am,
sense,
can I leave?
not in the liquid form. Yeah, some you can do in gaseous form also. You can make them. You have some melting point. Like you can melt them and make them as a liquid under some laboratory conditions, and you can mix them because HCl is already a liquid. Liquid. So this is a
Then
ferric
how
will
they
be metal.
separate
Yeah.
like hydrogen and make FeCl2? How do they like
Hydrogen is a gas liberated, so it's basically, it will be like you have ferrous powder, you will be having ferrous powder, you will have, so HCl will be here, so
and
you
what
will
is ferrous?
what?
What is ferrous?
Fe. Ferric, you can say ferric or ferrous, you can say iron. Basically, if it is only Fe, you can better say iron. No confusion. It is, if it is reacting with a chloride, based on the chloride L3 or Cl2, you can say ferric or ferrous. Better you can say, in this case, you can say just an iron, if for avoiding the confusion.
Ma'am, can I leave?
Okay. Do you have any work?
Yes, ma'am, I have a class. And
Okay,
also,
you can leave.
ma'am, actually the time is up.
Yeah, yeah, it's time. Actually, we are running 10 minutes late. Okay, fine. So we can stop here. We'll have the discussion next class. But you understood the equation, right? And
yes,
again, it
ma'am.
is proved that it is liberating salt plus hydrogen. Yes?
Okay.
Got it, everyone?
Yeah, bye, ma'am. Yes.
Got
Yes, ma'am.
Yeah, bye everyone. Bye.
Bye.
Thank you, ma'am.
Thank you.
ma'am. Bye.
Ma'am, for the objective test, what is going to
Thank
be
you,
the
ma'am.
topic?
Bye.
What, Advika?
Ma'am, for the objective test, what will be the topic?
I'll post in the group now. Don't worry.
Okay, ma'am. Thank you, ma'am. Bye, ma'am.
Thank you. Bye.